Okay, so we're going to try this one more time. So you say the third time's the charm. Actually, what had happened was there's a switch which I didn't notice when I was doing the first two recordings, that somehow got set off, which actually controlled the microphone. So we will do this one more time, talking about defining and collecting data. Okay, so really what we're looking at here is to begin. We're kind of at the start of our whole journey here. So one of the key concepts is this idea of variables. So we're going to talk about some of the characteristics of variables. So types, measurement scales, approaches to how you can collect data, and some different ways to collecting samples. All right. So what we're going to use is we're going to use the DECOVA method. All right. Which basically it's an acronym which stands for all the steps we're going to go through. So the first D in DECOVA is defining the data. All right. So what we're going to do is we're going to identify the variable type and then also the scales of measurement. All right, so there's really two types of variables that we're working with. One is what we call categorical. Those are qualitative in nature, so they're non-numerical. All right, so, and they are basically they describe categories or classifications. All right, and then the other one is quantitative. All right, quantitative variables are variables that are numerical, and they will have a value of some type which will represent either a counted or measured quality. Right, so we would call counting variables resulting from a counting process are discrete, and variables from a continuous process as a continuous variables are, are assigned to a measuring process. Right? So it's basically two types. So it's numbers and characteristics, basically descriptions or numbers. All right. Pictorially, kind of a representation here, visualization, categorical and numerical variables. Some examples of categorical, so things like marital status, political party, eye color. Those are all, potential characteristics that that we could use to describe maybe a person, or characteristics of people. Numerical, some examples of numerical for discrete, number of children, defects per hour. Those are counted items. And then for continuous, it's a measured characteristic, so it's weight or voltage as examples. All right. So in talking about the level of measurements, all right, with categorical, there's actually a further breakdown of the level of measurements in categorical. There's nominal and ordinal. All right, so nominal scale will classify data into categories in which no ranking is implied. All right. Ordinal scale classifies data into categories in which there is some type of ranking. Right, like low, medium, high would be maybe something we would put into an ordinal scale. Right, whereas eye color is there's no ranking in eye color or handedness. On the numerical side, right, they have their own. So there's a interval scale and a ratio scale. All right. So both are there's an equal distance, the distance between the measurements, or a meaningful quantity. And so basically what we'll have is a scale of which everything is of a common number. So everything, a range will be, the range between, for a category would be like from one, from greater than one, or greater than zero, um, less than 10, all right, which would give us 1 through 9. All right. And then ratio scale is, difference of the measurements is a meaningful quantity, and the measurements have a true 0 point. All right. So these are the two characteristics. So operational definitions. So, this is, in effect, what we're doing is business analytics is a business problem. It's a way of solving business problems. All right. So what we're doing is we're creating a structure, to handle this. So the way we tackle the problem is we kind of will gather some information, use it to create a structure, and then populate the structure with data. For example, sample data or whatever, and then analyze it. All right. So the first thing we want to do is we want to create an operational definition. All right. So it's defined as a precise, clear and precise statement, provides common understanding of meaning. And the reason it's important is because if we don't state this clearly and precisely, we can have miscommunications and we'll have errors. All right. So there's a level of discipline that we need to adhere to as we're doing this. All right. And, part of this first step, the D of Dekova, the defined step is this operational definition. All right. So let's look at C. Right? So C stands for collecting data. All right. So with data collection focus, sources of data, population versus sample data, sample selection, and data preparation. Topics we're going to be talking about here. All right. So, like I said, this is a business. We're doing an exercise to, deal with business problems. All right. So our first step is going to be the creation of a business objective. All right. And the business objective is really going to frame out, establish the scope of, our analysis. All right, so but what we'll do is we'll start from the business side. So we'll describe it in terms of business characteristics, and then we will continue to refine that to make it, to align it more around statistical processing or analysis. Some examples of business objectives. Marketing research analyst needs to assess the effectiveness of a new television advertisement. All right. So, if you look here, our objective is we're going to assess the effectiveness. It's a little vague, but we have an idea of what we have an idea of what that means. All right. Pharmaceutical manufacturer needs to determine whether a new drug is more effective than those currently in use. Or an auditor wants to review the financial transactions of the company to determine whether or not there's been fraud. All right. So each one of these is, stated in terms of a business objective, but we're not necessarily we don't have to be that precise in exactly what we're going to do. All right. So, determine whether a new drug is more effective. We'll need to focus in on, we'll need to, as you'll see as we go through our model, we'll need to define what more effective actually means. All right, so here's our as we said, our business objective really allows us to kind of sets the stage for us to turn to focus what the types of data and the types of analysis and comparisons we're going to be doing. So for the business side, we'll do our first one. Marketing research analyst needs to assess the effectiveness of a new television advertisement. All right, so we said assess effectiveness. All right. Now, if we frame this, if we kind of turn the objective into a question, we kind of flip it around a little bit. It's like, is the new television advertisement more effective than the current television advertisement? Okay, so once again, we have, our basis of comparison is going to be looking, evaluating effectiveness. Right? If we want to frame this in a statistical way, what we'll do is we'll be much more precise. We'll say, is the proportion of new television advertisement viewers who recalled the ad significantly greater? So, one thing is we're more effective. We're replacing more effective with significantly greater than the proportion of current television advertisement viewers who recall the ad. All right, and we still have here, in our statistical question, something we'll have to define as we move forward is what do we evaluate as being significantly greater, and that really is a function of whatever we're going to be measuring. Like some things, 0.01% is significantly greater. In other cases, 20% would be considered significantly greater. All right. Either one. So it's really it ties back to, once again, that will tie back into the business question and the business objectives. All right. So the sources of data that we're looking at, we have what we call primary sources and we have secondary sources. Primary sources means the data collector is the one using the data for the analysis. All right. So you would, so if you were, say, for example, a scientist setting up an experiment, and you're going to gather the results, you're going to be the primary source. Secondary sources, people performing data analysis is not the data collector. In large part, we'll be pulling from secondary sources. All right, and there's really, it's not necessarily, one is not necessarily better than the other. All right, but we do want to define what the source is. And our sources of data, there's really 5 categories of data. All right. So we have data distributed by an organization or an individual. We have outcomes of a designed experiment. We have responses from a survey, the results of conducting an observational study, and then data collected by ongoing business activity. So let's kind of dive into this a little bit. All right. So when we're looking at data distributed by organizations or individuals, some examples of these are going to be things like financial data reported by companies. Companies are required to publish their numbers, the financial numbers, on a scheduled basis. Right? So that could be used as a potential source of data. Combining the information from multiple organizations, and using that as our population to draw from. We can also draw from industry or market data from market research firms. And then, in non-business or non-industry or financial, things like stock prices, weather conditions, sports statistics. They're simply data, that is collected, organized, managed, distributed by either an organization or people. Data from a design experiment, a couple different things. We've consumer Consumer testing of different versions of a product. We can make a decision or try to evaluate which product should be pursued. Or market testing alternative product promotions to see which one is going to be more effective, which promotion to use more broadly, what's the more effective. From surveys, I think the biggest examples we see in surveys are going to be things like political polls of registered voters during political campaigns, or, for example, people being surveyed to determine their satisfaction with a recent product or service. Something I've noticed is that whenever I'm engaging with an organization, like I had last week, I was working with a phone company. All right. And even as I was speaking, they were sending messages, looking to get feedback on the effectiveness or the efficiency or my sense of how the engagement went. So, and we see more and more of that, of trying to gain, this is somebody's participated in something, and then get their feedback from it. Observational studies. A couple different examples of this. One would be measuring the time it takes for customers to be served in a fast food restaurant. That would be one. Another one would be the volume of traffic through an intersection. So what you would use, and then use that as a gauge to see whether or not it would make sense to put advertising there. So that's a couple. So this would be so this is just the observations. We record things as they were occurring, and then finally, the data collected from ongoing business activities. So, for example, a bank would study years of financial transactions, with the idea of helping them to identify patterns of fraud. Or marketing, and really what we see this one right here is a major part of businesses of these days in terms of analytics. Right? Because what happens is you can capture all sorts of little bits of information, inside of an email, inside of a web interaction. All right. And what happens is what you can do is you can strip. You basically, when you send the inbound transaction into into the web server, what it will do is it'll simply pull that stuff off and put it into a repository, and then you can come back and evaluate the effectiveness of the website, try to see if you can identify things like repeat customers or how much lingering time a customer would have on a particular web page. So when we collect data, it's either being collected from a population or from a sample. Right? Population is all items or individuals that you would want to draw a conclusion. All right. Can be anything, so long as we can describe it. What we want to be able to define. Okay, this is the scope of our population, what the characteristics are. A sample is a portion of that population that we select for analysis. All right, so we don't need to check everything. When we're working from a population, we don't need to do the entire population. What we're going to do is draw a sample from that population, and then from that develop an estimate of the characteristics of the overall population. All right, so there's a couple different ways to get samples. The idea behind samples are you want to have an unbiased sample. All right, so there's some things are a little more effective than others. Non-probability is probably your less reliable sampling. So, from judgment is something, you would kind of, you use your judgment to identify what you want to pull from a sample. So that could actually reflect some of your own biases, or convenience, which would be, let me go out and I'll survey the first 5 people I see on the street. Right? So, it is a sample. The question would be questions when, as you would evaluate it, you need to take that into account. Um, Probability samples is what we call random samples. Right? So, are simple, and there's a couple different ways we can approach this. A simple random sample is a selection of items from a population such that every item in that population would have an equal probability of being selected. If we do that, that means it's a random sample. All right. These other types of random samples basically require, are basically involving the kind of creation of a structure. Like, for example, stratify, what we do is we would take ranges of numbers and then select from that, select a sample from that. Or like systematic, what we could do is simply say what we'll do is we will pull every 5th number out of a population. Assuming it has a even distribution, that would be, that would be a systematic way of gathering items. Which basically, simple random is simply, you kind of mix everything up and you grab, for example, the first 5 you get. Right? So long as there's an equal probability that any of the units could have been in that population could have been chosen. All right. So one of the big problems, one of the big challenges with data is data cleansing. So we see this all through, in modern computing environments. It's like big data and analytics and things of that nature. You're only going to be as good as the data is, as the quality of the data. All right, which means we don't have errors in it. Things are consistent. There aren't holes in it. There aren't missing attributes or definitions. So a whole bunch of different things would make data irregular. Typographical errors, as we say here. Values that are impossible or undefined. We'll take, for example, you have a number. It should be between 1 and 5, and there's a 7 in there. That's that would not be fit within the range. Missing values, you get a lot of that. Outliers, which may, the question on outliers are, does it reflect an actual event, or is it just simply, an error? It could be generated by an error, but it could also reflect reality. So you'd have to take a look with outliers. And what happens is, usually what we'll do is that there's an old term we use in computing, which is garbage in, garbage out, GIGO. Right? So GIGO means we're only going to be as good if you put garbage into a computer, into a program. What you'll get at is going to be garbage. All right. It doesn't matter what the presentation is. It doesn't matter what the analysis is. It's only going to be as good as the numbers are. All right. So one of the activities we can be involved with when working with data is identifying irregularities and then reviewing them and addressing them. All right. So it's like data. We call it data cleansing. But it's it's part of our first step when we're working with data. And sometimes, when we have a collection, after we collect data, what we're going to do is we're going to assign it, we're going to look at the variable and we say, okay, is that categorical or is that numeric? All right. And some things are clearly, one or the other. All right. But then there's some which kind of can be one way or the other. So we use an example. Age. Age could be, considered a numeric variable, right? Um, but it also can be, you can think of it as um, as a description of something. A characteristic of an individual would be their age, right? So you could either treat it as a categorical or you could treat it as a numeric, depending upon what you want to do with it. Obviously, if you want to do some sort of calculation around the average age, well, you would treat it as numerical, all right. But if you wanted to you want to do an analysis of like ranges of certain ages, kind of what tier all the ages break out into, you can look at that as a more as a categorical, right? And we can do either one. So basically, you can go, we can recode a quantitative variable we can make it into a categorical. All right. So the only thing you want to be careful about is making sure that the new categories are mutually exclusive, that we don't have any overlaps, and they are, as we would say here, collectively exhaustive. So the idea is we cover all of the potential values. All right. And that is it for our first discussion.